So now that we've finished our lab on equilibrium, and that was a lot in that lab, measuring blue solutions and yellow solutions and green solutions. Now that we're doing our sort of post-lab analysis, hopefully some of this can make a little bit more sense. Remember, the purpose of this lab was to calculate an equilibrium constant. You can determine an equilibrium constant if you can determine equilibrium concentrations for any species that's in your equilibrium expression. Okay, so for our equilibrium expression, there were three parts. There was the amount of dye that was in the blue form. That was the basic form. There was the amount of dye that was in the protonated or yellow form. That was the acidic form. And then there was the H+ concentration, the proton concentration. So remember, we got these values from our green solution. So our green solution had some amount of blue, some amount of yellow, that's why it was green, and then we used a pH meter to determine how much the concentration of protons was. So you use your standard curve for your blue to figure out how much blue was there, your standard curve for your yellow to determine how much yellow was there, and then your pH meter to determine what the concentration of protons was from the pH value. So one of the things that's going to be important for sort of the post-lab analysis here is you're going to get three values. Remember, you had three green solutions. You're going to have an average of those, and you're going to compare that to what the literature value should be for the pKa. Remember, that P means you're going to take the negative log of the K value. That's what putting a P in front of means. Take the negative log of whatever that value is. So you're going to take your K value and you're going to take the minus log of it to get to a pKa value. And you're going to compare that to 7.1. My guess is you're not going to be exactly 7.1, so you have to determine and give me some reasons why you think you're not at 7.1. And I want you guys, many of you talked to me about, like, did my data follow the trend that I'd expect? Remember, you had a yellow-green solution, a green solution, and a blue-green solution. So did the amount of blueness follow what you'd expect? Did the amount of yellowness follow the trend that you'd expect? If it didn't, that could be a reason for a source of error. Our source of error is not I grabbed the wrong solution or I measured or weighed something incorrectly. Those are not valid sources of error. I want you to think, kind of constructively about this. I want you to really think about all of the values that go into determining an equilibrium constant. And if your value is not 7.1, if it's too high or too low, based on what you know happened in your experiment, tell me at least one of these species that you can justify as being either too high or too low. Okay, so you're going to have to think about if my numerator is smaller than it should be. That should make my equilibrium constant be larger than it should be. How does that relate then to a pKa value? Okay, so think about all of these things, and I need to have sort of a well thought out understanding and rationalization for your error discussion.